bozza, ukimuana, anainama, anainuka, ananahaya.
Hi everyone, and welcome to a session of Topology. Topology is my favorite branch of mathematics, and it studies the fundamental properties of shapes. For this session, you will need a pair of scissors, a pen, tape, and several strips of paper. Let's play a very simple experiment. We take our first strip of paper, we fold it like this, as a little cylinder, and then I will put tape to keep it together. I fold the strip like this, and I use the tape to keep it together. Now I take the pen and I draw in the middle of the cylinder a line. I take my pair of scissors, I fold it a little bit, I cut here in the middle, so I can start to cut through the entire line. Please stop the video now and try yourself and see what you get out of it. I'm almost at the end of it. I just have to cut the very last bit, and when I finish cutting, what I get is two separate strips of paper. So far, nothing weird. But let's go for our second experiment. I take another strip of paper, and this time I do something unusual. I take my strip of paper, I fold it like so, like before, but instead of gluing it like that, I take one of the two and I twist it, like so. And now I put the tape. Oh, I already noticed something weird. I started on this side, and now I'm on the other side. Why does that happen? Please stop the video now and try yourself. I'm almost at the end. I just need to cut the very last bit, and when I do so, I get not two, but one strip of paper, which is folded. Please stop the video now and discuss together why does this happen, and also how many times is the resulting strip twisted with itself. If you want to count the twists, you can cut the strip and keep the two sides, and then slowly you twist the strip once at a time and you count. Once, twice, 3 times. You count how many times you need to do it in order to get a proper cylinder. 4 times. After I folded 4 times, I get a cylinder. Okay, something weird happened. Let us continue our investigation, our topological investigation. I twist once my strip of paper like before, and I tape it like that. However, this time, when I take my pen, I don't want to draw a line in the middle, but I want to draw a line at 1/3 of the distance from the boundary. Okay, this is the result. I started from 1/3, and then I just kept following the strip until the end. Now I start from any point. I give it a small cut like that. I can insert the scissors, and I cut until the end. This time it will be longer because one round won't be enough. I'll have to do it twice. Please stop the video now and try yourself and see what you get. I'm almost at the end of it. I just cut the last bit and this is what I get. I get 2 strips, but they are linked. How comes? Please stop the video now and discuss together why this happens. And also, can you figure out how many twists does each strip of paper have? Let's try another experiment. This time I make my cylinder. I want to twist once, but I also want to twist a second time and glue it with the tape like so. And then I'm going to draw with my pen a line in the middle of it and cut through it. Please stop the video now and see what you get. I'm almost at the end. I give it a last cut and this is what I get. I get again 2 linked strips and each of them again is twisted. The last experiment that you can do with Moebius strips like that is again take a strip, give it 2 twists and then draw at the third of the boundary and cut through it and see if you get something different or if you get the same. Okay, now we have played with strips, and these kind of twisted strips are called Moebius strips by the mathematician who first studied them. Now we are going to play instead with Moebius crosses. We're going to need 2 strips of paper and I'm going to put them like so as a symmetric cross. And then I'm going to put the tape diagonally like so, and I'm going to fold the rest of the tape on the other side like that. And then with another piece of tape I'm going to do the same on the other diagonal. And here I obtain a cross. Each group of students will need 4 crosses like that. So how do we play with Moebius crosses? It's a little bit like playing with Moebius strips. Every time that you have 2 strips that come together, you can choose to glue them in the usual way, like a cylinder, or to give them a twist. And that's why we have 4 possibilities and 4 crosses. The first possibility is to glue them in the normal way, the first pair, and the second pair as well. The second possibility is to fold one pair in the normal way and the other pair in the Moebius way with 1 twist. The third possibility is to fold both pairs in the Moebius way with 1 twist, but in the same direction. And the last cross, we take the first pair and we twist it in one direction, and in the other pair we fold it in the opposite direction. Let me do the first cross. I take the first pair and I glue it without any twist. I take the second pair and I also glue it without any twist. Okay, let me do the second cross now. The first pair I glue it in the usual way, and the second pair I give it a twist. Okay, let me do the third cross. The first pair I want to twist it clockwise, and the second pair I'm also going to twist it clockwise. I will do now the last cross. The first pair I want to glue it clockwise, like so. Now the last pair I will glue it counterclockwise. Okay, now we have our 4 crosses folded, and for each of them I want to do something very easy. I take the scissors and I cut through half of each of the 2 strips. So I start from at any point and I cut through the middle of the first strip of the cross, and after I am done I start with the other one, and I cut so for each of the 4 crosses. Let us try together for the first cross, the one in which we glued both pairs in the usual way. I start from any point after I finish cutting the first strip, I want to cut through the other one. And what I get, it's a frame. Please stop the video now and try yourself in groups with all the 4 crosses and see what you get out of it. Here we are with the solutions. So from the first cross, the one in which each pair was glued in the normal way, what I got out of it was this, just a regular frame. From the second one, in which we only twisted one of the 2, I also got the same. How does this happen? We twisted it once, but it made no difference. And from the other 2, in one of the 2 cases, I got the one in which we twisted in the same direction. We got 2 untwisted pairs, like frames, but now they only have 2 edges instead of 4. Sorry, one is untwisted and the other one is actually twisted. And for the last case, in which we twisted the strips in the opposite direction, we actually got 2 little hearts linked together. Isn't it romantic? A part of topology deals with mathematical explanations and proofs about why this happens, and also deals with more complicated objects which live in spaces that are more than 3-dimensional. Okay, this was it. I hope you enjoyed, and enjoy the rest of your math camp. Ciao!